Hi guys, in this video I'm going to go through with you Additional Mathematics Form 5 Chapter 5 Probability Distribution Formative Exercise 5.2. My name is Terry. If you enjoyed this video, kindly like, subscribe and comment on how we can improve this video presentation. So let's get straight to this. So the first thing is you have a question about a fair coin. You toss it 4 times, right? You want to construct probability distribution table of getting the tails. So this is a binomial distribution, and in binomial distribution the probability of getting head and tail in this case will be the same, and your n is now 4 because you toss it 4 times. Your probability is 1/2. Yeah, because it's a fair coin, and if the probability of getting tail is half, the probability of getting not getting tail will be 1 minus half, which is also 1/2. So before you construct a probability distribution table, you need to calculate the probability for each values of x. Now remember, if you toss it 4 times, the minimum number of tails you can get is actually 0, and the maximum will be 4. So you need to calculate each and every one. We start with bx equals 0, and the formula goes like this: nc0, in this case 4c0, b is 1/2 power 0, q is also 1/2, and let's take 4 minus 0, this q is 4. Now maybe I'd like list down the formula if you're not sure. B equals to r ncr b power r q power n minus r. Okay, now my first value is 1/16. For bx equals to 1, we write this as 4c1, 1/2 power 1, 1/2 power 4 minus 1, which is 3. This will give us 4/16, 1/4. For x equals to 3, x equals to 2 first, yeah? X equals to 2, 4c2, 1/2 power 2, 1/2 power 2 as well. This is 3/8. For x equals to 3, 4c3, the probability b is 1/2 power 3, 4 minus 3 is 1. We'll still get 1/4. And lastly, for x equals to 4, the probability is 4c4, 1/2 power 4, 1/2 power 0, which is 1/16. Okay, so now that we've got all these values, so we're going to draw a table of values over here. So we start off with this is your x and the probability. This is 0, 1, 2, 3, and maximum is 4. Okay, sorry if it's a bit ugly, but ugliness is not a crime. So this is, yep, how it should be. Yeah. Okay, line's a bit long. Yeah, try not to be a perfectionist. Yeah, okay, all right. So yeah, let's look at the first one. The probability, you can leave it in fraction or decimal. Normally, if you want to draw a graph, we use in decimal. If it's just displaying on a table, so I think we will just leave it as fraction. So the first one is 1/16, second one is 1/4, 3/8, 1/4, and 1/16. Okay, just to take note, the answer given in textbook is in decimal, but it doesn't matter, it's the same. You can leave in decimal or fraction. Okay, let's move on to question number 2. Okay, question number 2, we have to construct a table and draw a graph. Okay, but here they are talking about the probability of getting a number greater than 3 when you toss a fair dice 3 times. So number 1, my n is 3. Okay, and the probability of getting a number greater than 3. Now remember, a number, if I think it's a coin, a die, normally we say a fair die, 2 fair dice. Die is singular, dice is plural, but anyway, it's okay. So this is 1, 2, 3, 4, 5, 6. More than 3, we are referring to 4, 5, 6. So they are 3 out of 6. So the probability is half, right? Now, let's start by calculating the value for each probability. Here you have a minimum of 0 and maximum of 3 because your n is 3. So let's start. 3c0, b power 0, q power 3. This will give us 1/8. Then we do x equals to 1, 3c1, b power 1, q power 2. This will give us 3/8. So as I want some space to calculate, to draw the table. So I'm going to write x equals to 2 over here, 3c2 b power 2 q power 1. 3 minus 2 is 1, so I will get 3 over 8 as well. And lastly, when px equals to 3, we put 3 inside here. 1 over 2 power 3, this is power 0, answer is 1 over 8. Okay, so let's draw the table, right? I only need four boxes. This is x equals r. You can write x equals to x. Sometimes we use x, sometimes we use r. It doesn't really matter, right? X equals to r. This is 0, 1, 2, maximum is 3. My minimum is 1 over 8. This is 3 over 8, 3 over 8, 1 over 8. Now, actually, by right, when you use graph, normally people use decimal. But however, I see the textbook, they use answers, they use fraction. It's still okay. It's still okay to use fraction, so I'll just stick to fraction. But you want to use decimal, can 1 over 8, 0.125, yeah, and so on. Okay, remember in the previous formative practice, so we have done something like this. We have done this graph for binomial distribution, but for general, what do you call that, discrete random variable, but this is specifically for binomial. Yeah, binomial, the shape is the same, exactly the same as discrete random variable. They're all single value, right? They are non-continuous graph, they are discrete. Okay, let me just draw this first. Yeah, so it looks like this. Yeah, okay, I can see that my line's a bit out. Yeah, but I think it's okay, right? This is x equals to r. Okay, now we can write big X, actually, it doesn't matter. So this is 0, 1, 2, 3. Maximum is 3, minimum is 0. For probability, you can see it's quite only two values you have to take, 1 over 8 and 3 over 8. But I'll just include 2 over 8 here, right? Quite a small graph. So the first one is 0. For x equals to 0, it would be at 1 over 8. So you put a cross here. Yeah, put a line. Okay, x equals to 1 is 3 over 8. This line here, then another 3 over 8. A line here, and lastly 1 over 8. Yeah, it's symmetrical, you can see. Yeah, because the probability is itself is 1 over 2, 1 over 2, and then your n is small, so yeah, you get a symmetrical graph. Okay, so that's it for number 2. Let's move on to question number 3. Okay, all right, question number 3. The probability that a pupil continue his study after Form 5 is 0.85. A sample of 8 pupil is chosen at random. Find the probability. Right, all these students continue studies after Form 5. Now, notice that sometimes you may notice that some books or some teachers will ask you to write like this. This is the symbol for binomial distribution. If you want to write, it's okay. Don't write, it's also all right. Yeah, this is x is a discrete random variable representing number of students that follows a binomial distribution. Your number of students in this case will be 8, a sample of 8 students, and the probability that they continue study after Form 5 is 0.85. Okay, so the first part, yeah, if you don't write this, again, I say this again, don't write this, right? N equals 8, P equals 0.85, that's fine. Okay, you don't need to write all this notation. So all these students continue studies after Form 5, so that means all 8 of them. So it's 8C8, P is 0.85, power 8, Q is 0.15. Remember, to get Q, you got to do 1 minus P, 0.15, and this will be power 0. You got to use your calculator, 0.2725. Okay, second, less than 3 continue their studies. Less than 3 means it can be 0, can be 1, can be 2. Can it be 3? No, just 0, 1, 2. Now, to calculate this, right, I think it's better to write one on top of another. It's easier to see. P x equals 0 is 8C0. Your P is 0.85, power 0. 0.15 power 8. Just right below here is easier to see, right? The next one is 8C1, 0.85 power 1, 0.15, 8 minus 1 is 7, then you plus 8C2, 0.85 power 2, 0.15 power 6. Okay, add them up, use your calculator. Now this is a very small number. Yeah, if you write in standard form, it will be 2.423 times 10 power negative 4, or you can write 0.00022423, right? As a guideline, always give your answer correct to 4 significant figure, right? Okay, so that is number 3. Moving on to number 4. So here we have a durian randomly chosen from a few baskets. So the probability that a durian chosen is rotten is 0.1. So find expected value and standard deviation. Okay, now when we talk about expected value, we're referring to mean. Now, number 1, let's identify your P. You can write P equals to 0.1. Your N is how many durian? 50. Again, you can write in this notation. You can write 50. P, don't write, never mind. Right. Now, mu is given by NP. Yeah. Mu is expected value, means on average. So if I take 50 durian on average, how many will be rotten? Answer 50 times 0.1, which is 5. Right. Now, how about standard deviation? Standard deviation is given by square root of NPQ. My N is 50, P 0.1. Remember, Q will be 1 minus P 0.9. Okay, so use your calculator. This will be square root 4.5, right? And I'll get 2.121, correct to 4 significant figure. All right, that's question number 4. Okay, moving on to question number 5. Okay, a binomial random variable x, yeah, has mean of 5, variance of 4. Find the values of n and p. Okay, so since they're written in this format, so we know your mean is 5, so np equals to 5. Yeah, we'll leave this as equation 1. Variance is 4, so can we say variance is npq is now 4, equation number 2. Okay, now in order to find n and p, I think I like to divide directly. Some people submit directly, you can. I'll take equation 2 divided by equation 1. So when you take npq divided by np, you get 4 over 5. Now notice you can cancel the np and np. Yeah, you get q first. My q is 4 over 5. You can write 0.8. But this is not what I want. Sorry, I need to find p. So what is the relationship between p and q? P plus q must be 1. So to find p from q, I take 1 minus q, which is 1 over 5. And to find the value of n, I need to sub inside, let's say, equation 1. Okay, I think I wrote this wrongly, guys. This is np. It looks like mu p. This is np. Sorry, mu is np. So now, your n is an unknown. P is 1 over 5. This is 5 and should be 25. Okay. Got your P, you got your N. Next, find the probability of x equals to 3. Now, in this case, your N is now 25. C3, P is 1 over 5, power 3, Q is 4 over 5. 25 minus 3 is 22. Okay, use your calculator. 0.1358. Okay, yeah, I think this is okay so far, right? Yeah, not difficult. Okay, moving on to question number 6. All right, here you're finding the value of p and the mean of x, given that this random variable x is a discrete random variable with n equals to 10, and your variance is 12 over 5. So we know we can start off by using the formula for variance, variance 12 over 5. So npq is 12 over 5. Since I know n, my n is 10, and I'm looking for p. So I guess it's better we just find the value. We straight away substitute q with 1 minus p, because you're finding p, right? So I don't want to write a lot of steps, like I don't want to form equation 1, equation 2, p plus q equals to 1. I think it's a bit long, so we just straight away write q as 1 minus p. And as you expand this, right, you notice you can actually multiply 50 over. So you get 50p minus 50 5b squared, yeah, I times over and expand directly. I hope you can do that mentally, and then you times the 5 over. This is now 12, right? And I think we can even simplify further, right? Can I divide by 5? Divide by 2, sorry. 25b minus 25b squared equals to 6. So rearrange the equation. Minus 25b plus 6 equals 0. And we can double bracket factorize this. 5b, 5b. Let me see. In order to get this will be 2, this should be 3, minus. So b is either 3 over 5 or 2 over 5. Yeah. To get 25, this should be 10 and 15. Minus 10 minus 15 is minus 25. Okay, I got two answers for p, but which one do I take? Let's say p is less than 0.5. Since p is less than 0.5, so we take 2 over 5 as the answer. Yeah, or 0.4. Now, once you got your p value, you want to find your mean. Very simple. Mean is np. Since my n is 10, my p is 2 over 5. My mu is just 4. Alright, that is part A. Part B, I want to find the probability that x is now 4. So, simple, use the formula 10, n is 10, c 4, p is 2 over 5, power 4, q is 3 over 5, power 6, and my answer is 0.2508. Yeah, just use your calculator. Alright, moving on. Question number 7. So this question is rather similar and rather simple, I would say. You have 20 pieces of fair coin. You toss it simultaneously, right? So n is 20. Fair coin, the chances of you getting tails will be the same as head, which is 1 over 2. Your q is also 1 over 2. You want to find mean. Mean is np, 20 times 1 over 2, which is just 10. For variance, we'll just take npq. Yeah, this will be just 5. Okay, very simple, I would say. Yep. Okay, question number 8. All right. In a survey, it is found that 1 out of 5 brand A calculator have lifespan more than 8 years. Right. So a sample consisting of n brand A calculator is chosen random. Find the probability. The probability lasted more than 8 is 0.0016. This is all. So it looks like this. Your probability is 1 over 5. 1 out of 5 have lifespan more than 8, right? I don't care so much about more than 8 years because it's just the probability. Okay, we don't have write x equals 8 or something like that. So if you have n calculator, all n of them lasted more than 8 years, your probability is 0.0016. So we write in this form. So use the formula NCN. B is 1 over 5 power n. Q is 4 over 5. Remember, if B is 1 over 5, Q is 1 minus 1 over 5. 1 minus 1 over 5, 4 over 5. So, okay. I can write this directly. This power 0. And we know anything power 0 equals 1. And NCN is also 1. If I have n item, I choose all n of them. It's only one way, right? So you're left with 1 over 5 power n. As for 0.0016, I think it's best we change the decimal to fraction, which is 1 over 625. And I hope you can see this now. 625 is actually 5 power 4. Don't have to use logarithm. We'll just write this as 1 over 5 power 4. By comparison, yeah, let me write down one more time. By comparison, n is just 4. Okay, yeah, not difficult. And the next one, find the probability that more than one calculator lasted more than 8 years. So remember, if you want more than one, right? Maybe I draw this for you. 0, 1, 2, 3, 4. My maximum is 4. If I want more than one, means I'm finding 2, 3, 4. So you have two options. Either you calculate the probability for x equals 2, 3, 4, add together, or we take total probability. We know that total probability is always what? The sum of probability is always 1. You can take 1 minus 0 and 1. You can still get the same answer. Yeah, it's up to you. But I think maybe it's a bit shorter if I use 1 minus. Let me write down 1 minus bx equals to 0 or 1. Now for x equals to 0, we use n is 4 now, c is 0, b is 1 over 5, power 0, q will be 4 over 5, 4 minus 0, which is 4, for c1, 1 over 5 power 1, 4 over 5 power 3, and you get 0.1808. Okay, and the last question, question number 9. Okay, so here we have a test consists of 16 multiple choice questions. Each question has 4 choices, so we know your n is now 16. Each question has 4 choices and one of which is correct. So the chances of you getting the correct answer or guessing the correct answer is 1 over 4. A pupil guesses the answer to every question, right? So you are guessing. Now, you cannot say that, the probability of getting a correct answer is 1 over 4 unless you say you have no knowledge about it, you're just guessing, right? Because guessing is 1 over 4. If you have knowledge about it, the chances of you getting the correct answer is actually probably higher, right? If you've been studying a lot, yep, you get higher chances of getting a correct answer. Now, first part A, estimate the probability, the number of questions guessed wrongly. Now, here's the problem. The chances of you guessing correctly is 1 over 4. Guessing incorrectly should be 3 over 4. So it's up to you. Some people find that it's very confusing. So maybe you have to redefine what you're finding. Okay, as in I put here, what is x? X is a discrete random variable representing what? Representing number of question guessed wrongly. So if you redefine as guessed wrongly, so now your x, again, you want to write this or not, up to you. Your n is 16, your p is now 3 over 4, not 1 over 4, because we want guessed wrongly. Yeah, previously this is guessed correctly. 1 over 4 is guessed correctly, guessed wrongly is 3 over 4. So if you want to estimate number of questions, we are actually referring to mean as expected value. So we take n times p, answer 12. So that means guess incorrectly. On average, you get 12 wrong, right? Okay, let's look at B. Now, find the probability that the student guessed wrongly all the question. All the question means what? X equals to all 16. All 16 guessed wrongly, all right? So this will be 16, C 16, 3 over 4 power 16, 1 over 4 power 0, I get 0.01002. By the way, if you don't want to redefine this, right, you can actually do it another way. As in, you say, okay, on average, I guess 16, 1 over 4, I get 4 correct. So on average, I get wrong. How many you guess wrongly? We take total, 16 minus 4, you get 12. Yeah, you can do that. And then for number of questions guessed wrongly means what? All wrong means 0 correct. 0 correct is 16C0, P 1 over 4 power 0, Q 3 over 4 power 16. Guess what? You get the same answer. Yeah. So just so you know, you can do this. You don't want to redefine it. Then you just use find the number of questions you guess correctly. Then you total minus. As for probability, we know if you guess all wrongly, that means you get 0 correct. Okay. Now let's look at part B. Okay, part B here. Passes the test if 60% is the passing mark. Okay, to know how many questions minimum number of questions you need to get correct to pass the exam. This is what I'll do. I'll take 60% of 100 times 16 questions. Now, if you calculate this, you get 9.6 questions. That means you need to get 9.6, but we can't get 9.6. 9.6 is not a discrete number, so we need to take the nearest integer. That means we need to n equals to 10. So you need a minimum of 10 questions to pass the exam. Now, to find and in this case now your n is 16. Your p, the probability of guessing correctly, is 1 over 4. Yeah, we need minimum of 10 questions correct. Now, when we say minimum of 10 questions correct, we are talking about 10, 11, 12, 13, 14, 15, 16. Whoa, this is very, very long. Now, if you to calculate one by one, we could write like 7 numbers add up. Yeah. So I would just use this notation. I wonder whether you've seen this before. This is summation, all right, of x start from 10 to 16. Now I use the general formula 16cx because x is a running number. X can be 10, 11, 12, 13, all the way until 16. The probability of guessing correctly is 1 over 4 power x. Wrongly is 3 over 4, 16 minus x. Now you can use your silver calculator, the Kssm calculator. You can actually, there's this function that you can actually key in, all right, and get the calculate directly. Yeah. So or you want to add one by one, go ahead. So I'm just not going to show you the one by one. It's very long. So just use this general formula, key in your calculator, and you will get 1.645 times 10 power negative 3. So I want to understand this. We are talking about a student pass a test. A student can pass a test if they get 10 correct, 11 correct, 12 correct, all the way until 16 correct, right? So I think a textbook answer, they only in textbook, they only give 1.359, and I guess this is based on x equals to 10, which is not correct, because you get 10 correct, you pass the test. How about if you get 11, 12, 13, 14, 15, correct? So you need to take the sum from 10 to 16 all the way, yeah? And the correct value is 1.645 times 10 power negative 3. Okay, that's the end of this practice. So again, just so before we go, just want to show you that if you are interested in more of our modules, right? We have some of the modules, past year question, practices, yeah, that you can get from our Shopee account. Yeah, just search for Pusat Tuition Teliti. All right, thank you for watching this video. I'll see you guys in the next video. All right.